of 2022. So welcome to the last Potpourri of 2022. We have a great lineup of member speakers today. Very excited to hear. There's quite a variety of topics for today. So why don't we start with Chris, who's going to share the Comet ZTF, a close approach. All yours, Chris.
Thank you, Swapna. I trust you can see my screen now, hopefully.
Yep. Yes, we can. Thank you.
Okay, thank you. I just want to let everybody know that there's an exciting event coming up in a month to two. A new comet has been discovered, Comet ZTF C-2000E3, and it's going to make a close approach in the next couple of months, and we're really hoping for another naked eye comet. Remember the one we had a few years ago? Well, maybe if we're really lucky, it'll be a repeat of that. So the Zwicky Transient Facility uses a 48-inch telescope on Mount Palomar, and it scans the entire northern sky every 2 days. So it discovers
Sorry, Chris, I muted you. Could you unmute yourself? I'm trying to. Can you hear me, Chris?
Okay.
Thanks. Yeah, sorry about that.
Okay, so I don't know if you heard the part from my first slide, but so there's a comet is coming that we're hoping is going to become naked eye, or certainly a binocular comet in the next 2 months. So it's very exciting because we all remember the comet that we had a few years ago. So it's called Comet ZTF C-2000-E3. So the Zwicky Transient Facility, which is ZTF, it's a professional and amateur collaboration that uses a 48-inch telescope, and it scans the entire northern sky every 2 days. So you could imagine that many asteroids and supernovas and comets have been discovered by this facility. Comets are named by when they're found. So this comet was discovered on March 2nd, 2022. That's why it's C-2022. E is the first part of March. So AB is January, CD is February, EF are March, E is the first half of March. This is the third comet that has been discovered anywhere from Earth. The third comet in the first half of March of this year. So that's how it gets its name. Okay, advance. Okay, there we go. Okay, so here the comet has it's got a very inclined orbit. It's now plunging towards the sun and towards the Earth, and they're going to meet up in the next get a very close approach in the next month or two. Right now, the comet is entering the constellation Corona Borealis. The latest magnitude that I could find on the comet websites is the comet is currently magnitude 9. It reaches perihelion, or closest to the Earth, on January 12th. It'll be 1.11 astronomical unit, and its closest approach to Earth is an exciting 0.28 astronomical units on February 2nd. Now that's really close. It's predicted to reach magnitude 5 or 6. From a dark site, that would be naked eye, and from the suburbs of the city, it'd be an easy binocular object. Another exciting thing is on February 5th, the comet, when it's near its brightest, will be only 1.5 degrees from the bright star Capella, so it'll be really easy to find. Here's a map, thanks to Sky Telescope, showing that the comet right now is just entering the constellation Corona Borealis. On the left, you could see the path of the comet from all of up to January 17th. So you can see that it's rapidly moving north. Now that's very good for us, because if the comet is far north, it becomes circumpolar, and you could see it all night long. And with the long winter nights, that's really great. So Again, on the right side, you can see its path in the second part of February. And notice I drew in Capella, and the comet will pass very close to Capella, as I mentioned, on February 5th. ZTF facility has also discovered, and it discovers many comets, but another one is going to be fairly bright, magnitude 9 in December, and it's yeah, you can see its path marked here, going through Draco right now. So that's pretty well the end of my talk. We really hope that this comet will become bright. Some comets fizzle and, you know, not much happens to them. Remember ISON from many years ago. Others, we don't think they'll be very good and they become spectacular. So we've got our fingers crossed that this comet will be a really good one. So thank you, everybody, for listening to this brief presentation.
Thank you, Chris. That was amazing. Quick question for you. In February, which direction of the sky should we be looking in? From Oakville or Mississauga?
Towards the north, below the near Polaris, you know, north and northeast.
Got
Chris,
it. Okay.
Chris, it's Randy. Do you have the perihelion date and the closest to Earth date?
Yes, I do. Perihelion is January 12th,
Okay.
and closest to Earth is February 2nd.
Okay. Yeah, once it's close to the North Celestial Pole, it'll be very easy to photograph because, of course, you probably don't need to track it much to get a half decent photo because it's not moving that much in the sky.
And look, end of January, you find the pointer stars in Ursa Major. They point to Polaris. Well, halfway towards Polaris, there's the comet. So that's where you look, like you look north at that time.
Yeah. The thing though is do you have an idea how many AU is it that perihelion? Did you have that on your thing?
Yeah, it's
One. Okay.
0.28, like a quarter of an astronaut. That's very close for a comet.
That's close to us, but the fact that it's 1.1 AU from the sun means it may not get major heating and break up. So that's good for us.
Well, that's probably why it's not a magnitude -1 or 0 and only a 4, 5, or 6.
Yeah.
But it hasn't, they think it might be a periodic comet, but the last approach would have been 50,000 years ago. So it hasn't been going around the sun that long. So it's a fairly fresh comet in that sense.
Great. Good stuff.
Oh, can I ask a question?
Yeah, absolutely.
I noticed the orbit is really weird. It's like 90%, practically perpendicular to our solar system. Is that fairly rare with comets? Because they're a little closer to our plane than that, aren't they?
No, comets are in the Oort cloud, so they're in a sphere around the sun. They're not in the ecliptic plane, so I don't think that's strange at all.
Okay, so they could be anywhere basically then.
Yeah.
Okay, thanks.
Maybe somebody else might have a better answer, but that's my understanding.
No, that's right, Chris. There have been many comets that have been like very high inclination or ecliptic inclination. So yeah, it just happens.
Thanks.
Okay. Any more questions for Chris? All right. Thank you so much, Chris. This was an excellent presentation.
Thank you, everybody.
Have a wonderful time with the family.
Thank you.
All right. We have Leslie up next with the lunar eclipse presentation. Leslie, we can't hear you in case you are.
Yeah, we can see your screen though.
Yeah.
Have to find the thing. There we go.
Yeah.
As you know, on November the 8th, there was a lunar eclipse. It was around, 6 o'clock in the morning. So a lot of people probably did not bother getting up to go and see it, but I like lunar eclipses, so I decided that I would do it. And to do a proper lunar eclipse, you kind of have to scope out the sky from where you want to take the eclipse. And so I did that a couple of days earlier because I happened to wake up early. And I discovered that I could not take it from my complex, within my complex, which is what I'd hoped to do. And I have a field across the road, which is part of the South Common complex. And it would have been ideal, except that there are coyotes there, and I didn't want to run into one of those. So I ended up taking it from a street, one of the streets just by my complex. And so I went out early on the actual morning of November the 8th to check out the street lights, because that's an issue when you're dealing with, you know, streets. And there was no traffic, practically none, which was good. So I did find a spot that would work. And so I came back in, got warm, picked up my camera, and I went out about 5:30 to actually set up. And I took 3 sets of images. And for the past couple of eclipses, I have been using the technique that I use for deep sky astrophotography of actually taking quite a few lights and a set of darks. And I found it worked quite well for lunar eclipses as well as deep sky. So I took 3 sets of lights and darks, no flats because I have no vignetting with my current lens. And I didn't have to take any biases. So I went out with my camera just on the tripod. It's an ordinary, you know, kind of upgraded Rebel Canon. It's a 55 to 250 millimeter lens. It's the kit lens if you want a long thing, but it's a very good lens. And so it worked out quite well. I did have an issue though, because by the time I got out there, there wasn't really a lot of uneclipsed moon showing. And so I really couldn't get focus on it. So I had to focus using a street light down the road, the furthest street light I could find, which wasn't perfect, but you know, what do you do at 6 o'clock in the morning? If I had been taking it from my backyard, I would have gone out when the moon was still, you know, bright and actually focused at that time. But anyway, life goes on and you deal with what you have. So as I say, I took 3 sets of images. I took 5 or 6 lights and 10 darks for each of these 3 sets. One set was at 1.5 seconds exposure. One was at 2 seconds and one was at 2.5 seconds. Well, the 2.5 seconds turned out to be far too bright. The 1.5 seconds was probably the best from an exposure point of view, but it wasn't very sharp. So I went with the 2 seconds. And I took the set and I actually processed that particular set. It ended up being only 4 lights because one of them was really not in focus enough. And the 10 darks, of course, were fine. So I converted them, I shoot RAW, and I converted them using Canon software, DPP, to TIFF. And I put them through a program called Linkios. I run a Mac system, so I don't have the same number of choices as people that run on Windows. So Linkios worked. It's you can't use a lot of the normal stacking programs that are used for stars because it's a different kind of stacking that you do with a planet or the moon because it's actually turning itself. So that's why I had to look for this Linkios program, which worked quite well. It took me a couple of tries to figure out how to do it because I'm not very experienced with it, but it did work. And then I took the finished, stacked and aligned photo into Affinity Photo, which is what I use for post-processing all of my pictures. And I didn't do much to it, the picture itself. I did a little bit of darkening on the moon because I would have been happier with the exposure at 1.5 seconds. But so I darkened the moon a little bit. I added some clarity and some high pass sharpening just to the moon. And then I cropped it. And I was really quite pleased with how the thing had turned out. And, you know, it's probably stacks up there with some of my other nice lunar eclipse images. So I was happy. And I was back in the house by about 6:15. So, you know, I didn't get frozen to death or anything while I was doing it. So it worked out well. And does anybody have any questions? It's kind of short and sweet, but you know, there was nothing really complicated in putting this together outside of the stacking and the alignment part of it. But that worked out fine in the end anyway.
Leslie, could you zoom in on it a little bit?
Could I zoom in on it? Probably.
Just kind of small. Oh, it looks great. Yeah, very smooth.
Well, the darks help, you know, with the hot pixels, and my camera unfortunately has a lot of hot pixels, as I discovered when I took Neo-Wise, and I had to remove them manually, and I gave up counting after 100, and there were many, many more. So I've become very conscious of that. And I would have liked it to be a bit sharper, but you know, I don't feel I had perfect focus just because I had to go against this street light in the distance, and it was lights are very difficult to focus on. It would have been much nicer had I been able to focus on the moon, you know, or the bright side of the moon earlier in the evening, but I wasn't going to leave my camera or anything outside for an hour, and I wasn't going to stand there for an hour. So I had to deal with what I had to deal with.
Well, it turned out well. Looks very good.
Yeah, beautiful picture. What kind of camera did you use, Leslie?
It's just a Canon 77D. So it's, you know, it's of the Rebel line, but it's got some of the features of, say, the 80D. And it's, I mean, it's a 2017 version, so it's 5 years old, but it still takes beautiful pictures. And they say the kit lens, the 55 to 250 millimeter STM lens is really quite sharp. Kit lenses have come a long way since I first started doing photography way back in, you know, 2006 or so. And so they're really not bad at all.
No, that's nice, Leslie. Can you zoom out a little bit?
Can I zoom out?
Yeah. Shaquille just pointed this out, but I wanted to also mention a couple things. I love how the southern part of the moon, which is closer to the center of the shadow, is darker, and you get various darkening, and then the yellows and oranges at the top. That's great. And also at the top left, the two stars, the brighter one to the left, to the right of the two stars on the top left hand. You've captured Uranus there, which is really
I thought that might be it. I was trying to find out, because there was chat information on the chat about Uranus there, but I wasn't quite sure because I'm trying to match my stars up in the picture to, you know, star maps and stuff. And so that's good then.
Yeah, no, I just did a quick check, and all these other stars align with the various stars in Aries. So yeah, very well done. Beautiful pick.
Thank you.
It's a prize winner, Leslie. It's very good.
Thanks. Yeah.
Don't set it in a photo contest because you're one of the judges.
I can't, right.
Any other questions for Leslie? All right, thank you, Leslie. Gorgeous picture. Up next is Kirby, also sharing a nice lunar eclipse picture. Kirby, all yours.
Okay, good evening, everybody. Really great work, Leslie. Thanks for that. Let me just share my screen. Try to get this to full size. How does that look? Does that look full size on your screen, everybody?
Looks good.
Okay. So yeah, I was out that night too. I think a lot of us were. We were lucky to have nice weather for that eclipse. Unlike the occultation of Mars this week, which would have been great to see. I think a lot of us were clouded out for that little puppy, but for this one, the weather was really, really great. So I threw in just a slide or two for those of you that might be a little bit less familiar with how these things kind of play out. So this one is courtesy of Fred Espenac, of course, one of the eclipse experts in the world, and this exact diagram appears in our own observer's handbook from the RASC. But this is a diagram of the eclipse event that Leslie just described. And for those of you a little less familiar, there's an outer penumbral shadow, which is not very dim at all. And in fact, when the moon is entering that, it's almost imperceptible. I've never really seen a lot of difference with my own eye on a moon that sits in that penumbral shadow. But as it approaches this U1 point where it starts to enter the much darker penumbral shadow of the Earth, then we definitely start to see a darkening on that upper left limb, and it will continue to progress until it's all the way inside the penumbral shadow, and that's the U2 point. And down here I just took Fred's UT times and converted them to Eastern Standard Times that I was using that night to kind of organize myself. So you can see that U2 time was around 5:16 a.m. And then it progresses through the dark part of the shadow. And as Randy pointed out a minute ago, even when it's at its deepest point in the shadow, the upper right limb of the moon, we could expect that to be a little bit lighter because it's closer to this brighter penumbral part of the shadow than the southern part of the limb is. So, and that's exactly what we see photographically, of course. And then as it progresses further, it gets to around 6:41, it reaches the U3 point where that upper left limb of the moon will start to exit the penumbral shadow and brighten dramatically as it starts to move out, and eventually the moon moves through the penumbral shadow and completely out of the eclipse. Now for us, we were really only seeing the ingress portion of the eclipse. We could only see it through till about halfway, because for us the moon set at around 6:30. Mid-eclipse here would be between this U2 and U3 point at about 6 o'clock, and one of my photos was taken right about that time. So that's kind of mid-eclipse. But from where I was, at least by about 6:20 or 6:25, the moon was really deep into the murk in the east and basically set. And at the same time, the sun was coming up and brightening the whole sky. So I was surprised at how quickly the moon started to disappear by kind of going into the murk in the east, and at the same time as the sun coming up behind us in the west. And in this diagram, also from Fred Espinac, just shows that what I described earlier, that for us in southwestern Ontario, we saw the eclipse from the beginning of the eclipse through to about halfway, and then the moon set at about the mid-eclipse point. So, for this event, this is the stuff that I took. I went out to my sister's place in Vineland. Idis and a few of you may have been at that location for our dark sky observing back in October. About 20 club members went out there for that. So here I am set up in her backyard. Of course, I didn't have to go to a dark sky site to see an eclipse, but I wanted to have a fairly clear eastern horizon, and I thought it might be neat to try to do a time lapse over top of my sister's house. So I came with a few sets of equipment. On the left side here, I've got a Canon 70D DSLR with a 400 millimeter telephoto lens, and so that's what I was using for close-ups. And I had that on a Skywatcher Adventure tracking mount. That probably wasn't critical to have, but I just found it convenient because then, you know, every 10 minutes or so I would do another round of shots in both camera systems, and it was just a lot more convenient to have that telephoto lens tracking fairly accurately on the moon and kind of keeping the moon in view. So that was what I used for close-ups. In the middle on this little table are a couple of pairs of binoculars, a 7x50 Bushnell binoculars, and I brought 15x70 Celestron binoculars, which I love to use for lunar eclipses. And then on the right side is the other camera system I took. I used my other DSLR, a Canon 6D DSLR. That camera has a full frame chip, so it's got a much wider field of view, especially when you couple it with a pretty wide angle lens, which I did. I had a zoom lens on it, which I set to 30 millimeters, which is quite wide angle. And I set that up on a fixed tripod so that I could try to do a bit of a time lapse over top of my sister's house and try to capture that whole first half of the eclipse before the moon is set. So that's the equipment. So here's the wide angle one that I took with that 30 millimeter lens and the 6D DSLR. You know, in hindsight, you know, 30 millimeters was awfully wide angle. The moons are very tiny in this photo, although it's not too bad, maybe at full size. But I could tell when I was out there at about 3:55 and getting ready for the beginning of the eclipse, I could see that the moon was directly above my sister's house. And I could tell from some of my apps that it was probably going to set around this tree over here. So, you know, I kind of set the zoom lens to be able to capture the whole first half of the eclipse, and that took me to 30 millimeters, which, as I said, is pretty wide angle. You get pretty small moons. But I think it worked out fine. I think you can see the exposures here. About every 10 minutes, I would do another round of shots, and these are and each of those rounds, I would take a variety of exposures so that I could choose the one that I liked at the end when I got them all on the computer. So I ended up really taking 16 shots about 10 minutes apart. The first 4 or 5 were all just shot at about 500th of a second, everything at f9.5, about 500th of a second for the first 5. And then I needed to start increasing the exposures or selecting ones that had a longer exposure when I finally got them on the computer, because the moon was getting pretty dim as it got very, very deep into that umbral shadow. So down to 180, 190, 1/8. And then once it was fully into the umbral shadow, then I really dialed up the exposure to start capturing the red. And you can start capturing the red a bit earlier. If you did a longer exposure on some of these ones, in here you would pick up some red. The challenge with that, though, is that it will drastically overexpose the part of the moon that is not exposed, or that is not eclipsed yet. And so I usually wait until the moon is pretty much completely into the umbral shadow before I dial up and go after the red. And so that's why you suddenly see an increase in red. And most of those were done in about 2 seconds. Towards the end, when the moon was getting low into the murk in the east and the sun coming up behind me, I used a longer exposure of about 3 seconds or so for the last couple. But I was fairly happy with this collage, because I did accomplish what I wanted to do, which was to capture the whole first half of the event over my sister's house. And I even managed to get a few of her photos on the wall coming through the window. And then up in the upper left here, you can see Orion that I captured in one of the last frames, and kind of brought that out. So in terms of processing, not nearly as sophisticated as Leslie, but I just picked the best exposure sub for each of the 16 rounds. Grabbed the raw versions of those and pulled them into Photoshop as separate layers. They stacked up very well, just in line like this, almost perfectly, because the tripod was fixed the whole time. So they stacked up real well. On a few of them, the last few, I had to mask the moon so that I was only getting the moon, because by these last few, the sky was getting very bright with the sun starting to and close to rising behind me. So the last few I had to mask so that I would only have the moon and not the sky. This sky background, I think, is from about maybe this one or so. About this one, at about a 2-second exposure, picked up the sky looking like this, and the last 3 I just masked the sky out. So that's a little bit about the processing that I did that one. So that's the wide angle. And then over on my telephoto lens with the 400 millimeter L series telephoto. Again, I took a set of shots about every 5 minutes or so, and then just selected the best ones that I liked. I ended up putting together this little collage of capturing 5 moments, one 250th of a second at about 426, an 800th of a second at about 449, a 250th of a second at about 5. And then in here, much longer exposures, 1/3 of a second at 522 and 2.5 seconds at 602. So this one would have been about mid eclipse. And as I said, these are not as sophisticated in processing as Leslie's. So probably not quite as sharp in processing. I did pull them into Photoshop, had to crop them down, combine them into one photo. I applied a little bit of brightness contrast on a few of them, and a little bit of sharpening. Just to kind of to tighten them up a little bit on the focus, because as Leslie says, it is actually quite surprisingly difficult to focus on an eclipse moon, because we're looking at a full moon that is not showing any relief along the terminator. There is no terminator, so it's actually quite hard, I find, especially with the long telephoto lenses, to focus really, really accurately. So I think everybody probably struggles with that to a degree. And then I'll just leave you with this one. This is just the mid eclipse shot, just as it came out of the camera without any adjustments. You can see it capturing a few stars here, a little bit of brightening still in the upper right, as we would expect at mid eclipse. And I think this is probably too to telephoto to be able to catch Uranus, which was probably outside of the field of view of this photo. So that was my experience. Another fun eclipse. And thanks for listening. Any questions? Okay, I'll take that as a no. Thanks for listening, everybody.
Very nice, Kirby.
Just admitting Swapna again. I guess she got booted out.
All right, sorry about that. We had a technical difficulty here. All right, thank you, Kirby. Really appreciate it. Any questions for Kirby?
No, I think he explained it very well.
Okay, awesome. All right, why don't we invite up our next speaker, Gary?
Okay. Well, thanks. Let me start sharing my screen here, and here we are. And hopefully that's looking good. All right. Yeah, no, well, thanks so much for organizing this, Rob and Swapna. I really appreciate it. This has been a big sort of period of change for me, and I'll fill you in on that story. So I've got sort of a two-part talk here, and so it starts last June when I made a decision. So I retired from UTM a couple of years ago. I'm keeping my lab going there, but I don't need to be around Mississauga all the time. And for many, many reasons, I decided to make the move during this horrific real estate boom. It was quite a challenge. That's a whole other story. So I'll try to stick to the script here. And so I moved down to a little community near Dunnville, Ontario on Lake Erie. The community I live in is called Lowbanks, and next door is Highbanks, and that's a whole other story too. But it's really an incredible area. And you'll see that Rock Point Provincial Park is nearby, and a number of other great features of this area. And one of the benefits too, besides where I'm living, is that if I go out to Rock Point Provincial Park, where I have that yellow line pretty regularly, and I get some amazing views of the sky, like this one. And we have this heritage lighthouse in the bay, which adds some real sort of sparkle to the whole situation. But one of the great things about where I live right now is this incredible views of the southern sky. And out over Lake Erie, the skies are sort of Bortle 3 or 2. They're quite dark. And then behind me and over to the left in this image, you get into the sort of St. Catharines and Welland and that area. So the skies aren't the greatest, but they're still pretty good. And so there's some variation in the sky quality, but it's really terrific all in all. I also have an opportunity. So everyone who lives in this neighborhood it helps maintain 6 acres of park along the lakeshore. And I run out there with my telescope, and I've run out there with my camera and do some shooting. And whoops, what's going on here? Whoops, sorry, for some reason it's anyway, there's a refresher. So this is my place in the center, and people kind of chide me for moving from Mississauga to an area that where I have an even bigger yard than I had in Mississauga. But the great thing is that it's perfect for an observatory. So it took me a while to figure out where the sweet spot was, but it turns out to be right in this back corner. It kind of minimizes my neighbor's roof. I can shoot to the east or to the east between these houses, and then I get good views everywhere. And this is the view to the south. Whoops. From my place, you saw the daytime view. And one evening I went out and did this shot of the Milky Way. It's a stacked picture of the core of the Milky Way. And so you get some glow of the light. The light you see in the background there is actually from, I believe the one on the left there is Upper New York State. But what I did in order to get my my observatory going was I have a pod, a SkyShed pod that that Wayne Parker designs and builds. And he used to build these roll-off sheds, and he had a builder who did them for him. But about 20 years ago or so, he stopped doing this and moved into the prefab observatory business. But he sells these, and if you don't know Wayne, he's an amazing guy, and he's intense. This is him back in the 1980s. You know, he's a member of he was a bass player for Glass. That's one of their hits. But this is the kind of plans that Wayne supplies, and I was trying to figure out whether I'd do it myself or whether I would find a company locally to build it. And I kept driving by these sheds, this company, North Shore Shed Company, whenever I was in Dunnville. So I just gave them a call and we hit it off. I mean, these guys, it's a father-son team with a partner who manages the business. And we got to talking and they were excited about the project and said they could do it. And so once we agreed to get the project on the road, we took a trip up to Ron Brecher's place north of Guelph and visited his, and he showed us how it was built. He showed us the features of it. He mentioned what he'd do differently next time if he were to rebuild. So we were able to learn from his experience. So we went ahead and started to build it. And fortunately, North Shore Shed Company has a huge workshop, and coincidentally, it's just up the street from me, as it turns out. And so they built it in this indoor workshop, and I visited every day, and we discussed issues and what the best solutions were. And they proceeded to build it kind of the way they normally build their sheds, but with all of the modifications for the roll-off. And you can see that the garage door rails are in place. That roof can move now, can slide on those rails, as you see it in that bottom picture. And it really began to take shape. And one of the things I wanted to be careful about is I really wanted this to be rugged, because I'm right on the lake, essentially. We get these amazing winds off Lake Erie, and last weekend they were gusting up to 100 kilometers per hour, and it withstood it quite nicely. And this was it just before it was finished. We gave one last look to see if there's anything else we needed to do with it, and then they showed up to deliver. And I have this brief video, and there's a bit of audio to it, but it's not crucial. So I'll just show it to you here. And I was curious how they were going to deliver it. It was an amazing job. And the fellow with that machine in the back, he could maneuver that within centimeters of where he needed it. And you'll see in a second, probably the biggest challenge in the construction, which was not what I was expecting. We measured my gate before the shed came, and it was exactly what it ought to be, but it was great. But the machine just was absolutely remarkable. I decided not to put this on sonotube for posts because it's essentially separate from the telescope. But it needs to be relatively level so the roof can slide through.
Gary, we can't actually hear you over the music. It's FYI. Thank you.
I can turn that down a bit. So yeah, we didn't need to, can you hear me okay there now? We didn't need to
All
make
good.
it too particularly level because it's separate from the telescope. And then the second day, which was the day before the eclipse, which is tight, was when they put in the structure to roll the roof onto. And they made extra effort to make this incredibly secure. And the posts here are set into the ground about 3-4 feet. So that's quite strong. And then it rolled off really quite nicely. And now I have this very convenient situation. At some point I'd love to motorize it, but that's down the road. And I managed to get my gear set up, and my first light was the sun, believe it or not, and managed to get it going. So I have an Opton CM 120 in there, pretty substantial, and I have 3 OTAs that I use in there. A 115mm refractor and a 156mm refractor, and the big thing about that is it's long, and it fits beautifully in there. And then I have a Meade 10-inch SCT, so everything works beautifully in there. And then I did a better solar imaging set not long after that, and we can chat about that later down the road. I've been doing some nighttime imaging as well, and the dark skies here are phenomenal. But part 2, we can talk about the SkyShed in a second, but let me just do my Eclipse story here very quickly. So like the rest of you, I got up fairly early, but I had set up both a DSLR with a zoom lens on it on my SkyGuider Pro, and mainly to so I wouldn't have to recompose. And this business of constantly having to compose your image is just not on. So I managed to set the gear up the night before. So I got up around 5:15 and went out, and it was pretty bright. You could see your shadow. It was extremely bright, almost like daytime. But then when the eclipse became fuller and fuller, it just became pitch dark. And it's the first time for me to see a lunar eclipse in a relatively dark sky area. And the funny story about that is that I told all my neighbors about this, and my next door neighbors who are interested in the stars too, they were out. And as soon as it got pitch dark, I couldn't see anything in front of me. And these people started talking to me, and it scared me to death. And it wasn't until I walked about a meter from them that I actually saw them standing next to our shared fence, and we began to chat. So anyway, so I shot this to compose the Pleiades along with the moon. And you can see this is very close to sunset on November 8th. And this is a single 6-second exposure, and I have made some adjustments in Lightroom, just some basic denoising, some saturation issues, and brought out the highlights a bit while masking the moon, so it didn't wash out as well. So I was able to play with the Pleiades and the moon and get them balanced. And curiously enough, I pulled a shot from a year ago. And this was the lunar eclipse next to the Pleiades that I shot from Mississauga back in November of 2021. A little earlier in the morning, the moon was closer to the Pleiades, cooperated a bit more, which was kind of nice. I really enjoyed that. But in this case, it was just fortunate that I was able to shoot between my house and my neighbor's house. Otherwise, I don't know that I would have got it from my backyard. Would have had to have done something else. And then my final shot, it was this one. It's a bit, the highlights are a bit washed out on the top, I can see, but I shot this one using the standard Lucky imaging. So I used my 115mm refractor with my ASI 2600 cooled camera. It wasn't cooled, of course, but And I shot, I think about 500 frames, and then I stacked them in Auto Stacker. I did a little clearing up in Registax, and then brought it into Photoshop and just did some fine tuning of the color, the saturation, and so on. And this is what I got. So that's my story, and happy to entertain some questions.
Beautiful. Love the SkyShed. How long did it?
And now that I'm feeling, the only thing that I haven't done is that I booked an electrician 4 months ago, well before this went in, to get the electrical in. I'm still not in line for them to come and put hook it up to my circuit and put a box in and get outlets and all of that. So I'm still running it from an extension cord.
Oh boy.
But such is life.
Can you get data in there as well, Gary?
Yes, so I have I've got, if you mean, I've got an extremely long Ethernet cable running out to my computer. So I run it all from a Primaluce Eagle 4 Pro computer. And so it handles the power distribution, all my USBs. I hook up to the CM120 with It's absolutely great. I was getting these conflicts with my drivers, and as soon as Steve Malia suggested I try to run the CM from the computer using an Ethernet cable, I did that. All the problems went away, and now everything just works smoothly. And so I can set it all up, and I can now sit in the house with my Ethernet connected computer and run everything from in the house. And of course, the dream would be able to roll off the roof when I'm in the house, but I'm spoiled as it is. So,
how long did it take for you to, from start to finish, from a SkyShed perspective? How long was that process?
So from the first screw going in, it was about a week, and then 2 days to install. So these are professional shed builders, and they knew exactly what to do. And unfortunately, the builder got COVID, and it slowed the whole process down a day or two. And then I got COVID, and COVID just ran rampant through this area, Dunnville area. And I wear a mask when I go out generally, and I'm trying to be careful, but it's just very contagious. So, but the planning, I mean, from my first, I called these folks in early July, and the planning and convincing them and getting in line took a long time. And they have more people wanting sheds than they have time for. And one of the big things down here is that people want to build bunkies, and they want to run, they want to rent them out. And so people are putting in orders for 6 and 7 or 8 structures. But fortunately, because I got in touch with them back in July, they made sure that I was really ahead in the lineup, so I was able to get it built.
Excellent. Any more questions for Gary? All right, thank you, Gary. Amazing presentation. Thank you so much. All right, we have Bhavi next, designing a more inclusive future for space exploration. Bhavi, take it away.
Great. I'm just going to share my screen. One sec. Is my screen visible?
Yeah, it is. Thank you.
Okay. So I'm going to talk about designing a more inclusive future for space exploration. Before that, I'm going to introduce myself. So I'm an 11-year-old space tech and AI enthusiast. I've been with RASC since I guess I was 9 years old, and I love it. So I've spoke at I think 3 other Potpourri meetings, and it's pretty much a great place to be. And I've attended many of the events they host. So To spread awareness about space, I also conduct space camps during my school holidays to raise awareness among students. And yeah, let's get started. So I'm going to be talking about our progress in like human space exploration and how diverse it is. First starting off with like how we are right now, how it's all going, and then going on to what Morgan Stanley is doing to make space exploration more diverse and for everyone, and how I contributed in this project. So let's get started. So let's talk about the progress now. So everyone's aware about the 1965 launch to the moon, and it's a huge milestone in humanity's journey of sending humans to space. So the most fundamental when going to space, something that we can't survive without is spacesuits. And the initial spacesuits created by NASA were actually made to fit the all-male personnel that flew in the early 1960s and touched down on the moon. And the constraints of NASA suits have became an increasing cause of discomfort because the agency's gone much more diverse, both in space and on Earth. And more than 57 Canadian and American women have flown on a space shuttle or have spent time on the ISS. And here's a situation that happened in actually one of NASA's missions. Because they didn't carry enough spacesuits to fit both Anne McClain and Christina Koch, the authorities, they called off the first all-female spacewalk. And McClain was actually substituted for a male astronaut. So yes, we've had many, many advances in the space industry, but when we have diversity, there are a lot of flaws that remain. And despite the fact that NASA and the Canadian Space Agency, they've been operational for over 50 years, and that hundreds of billions of dollars have been spent on the space programs. And spacesuits have traditionally been designed for male astronauts. And despite the efforts everyone's putting in, just 17 of the 240 astronauts who've done spacewalks are women. Now, many women won't be comfortable in spacesuits originally designed for men, so we can't expect more women to aspire a career as an astronaut. So to address that, Morgan Stanley is actually looking into this project, and they've designed something that can really benefit here. So everyone knows about Artemis, and the SLS has launched, I think it was like a few weeks ago. And the next step is to send astronauts to the moon. So Morgan Stanley was aware of this critical gap and the need to see a more diverse future in spaceflight. So they created the Access One. So it's a prototype version of a suit made to accommodate a wider range of people than the current spacesuits. And this spacesuit was designed by space scientists, historians, and designers who, in collaboration, and with more women participating in the future space, which Morgan Stanley sees as a big area of growth. And it's one of the goals for the conceptual Access One spacesuit. So I'm pretty excited about this. So let's talk a little bit about how theirs are different to normal spacesuits. So spacesuits are much more than just baggy overclothes. They're like a miniature spacecraft in the form of humans that are designed to recreate Earth, but in a completely different place. They duplicate the microgravity conditions, and they also shield astronauts from radiation and extreme temperature changes. So the Access One includes communication systems, heaters in the gloves, so the astronauts can keep their warmth in the freezing cold. And for all of the parts to function as intended and for astronauts to perform safely in the environment, these vessels have to fit perfectly. So they have more flexibility, adjustable pieces, and this allows everyone to be more comfortable when performing essential tasks in space. When you feel better, you do better. So this is how I contributed in this. So it inspires me to see more women in the space industry. And Morgan Stanley invited me and 7 other girls to be a small part in a documentary they were hosting. So I was downright excited, and not only to be a part of a documentary where I get to meet an astronaut and a space designer, but also for the fact that it can play a small part in showing the message space is for everyone. So it was very exciting, and we all got to play, and we all got to experiment, but it enables more inclusivity, and it's a really amazing design, and it also alerts that all astronauts should have an accessible and personalized spacesuit that's comfortable. So I've got the link to the documentary, and it's like a 5-minute one. So I can put it in the chat right here, and pretty much it's just a few minutes, but it shows really how much this can change and can benefit when we go into space exploration. So that was my experience. Thank you.
Wow, Bhavi, that was amazing. Congratulations. So proud of you.
Thank you.
Did you get to try on the spacesuit?
Yes. So we actually helped the space designer try the spacesuit out, and we actually got to help her add on the different pieces, and we got to note down like how this piece works, how it looks like when she bends down, how can she walk with it. And we got to try out the helmet part of it, which is the picture you saw, and it was really cool. It did have more space, and it was pretty exciting.
Oh, awesome. Any questions for Bhavi?
Bobby, Randy here, were they specific lunar surface, Mars surface suits, or were they for zero-G spacewalk suits?
Sorry, could you repeat that? That was a little muffled.
The spacesuits that you were looking at, were they designed for just spacewalks, or were they for like lunar surface?
In this case, I guess they're in lunar surface, because actually the place we went to, it was a dome, and they had they duplicated, they had like the sand that represented the lunar surface, and it was actually like, it was kind of like walking on the ground, so it was designed mainly for the lunar surface.
Spacesuits are different designs. Some of them are like all very soft, like you saw with the Apollo stuff, right? And some of them are like hard torso.
Yeah.
Did they have a combination of hard torso, soft legs, or what were they?
Yeah, so I think this one was especially for when you're actually in, like when you're in the ISS, you have you're wearing the spacesuits that you have when you launch. So the ones that you saw from the pictures, they're actually for the indoor part. But when you're actually doing the lunar surface walk, it's the ones that are like really thick and like the baggy ones.
Okay. So for, the concern of not having the suits on the space station for the women, I think was just a size issue, not necessarily because they were women. Did you see that the suits were like various sizes, or were each suit something that you could adjust based on the person's size?
This one is especially personalized to specific people. So actually, they had canceled out the small spacesuits, so there was only extra large, and medium. So there were no small, so it didn't fit many women. That's why they designed this. So it was especially to also fit that size.
Cool. Well, what a great experience. Thanks for sharing this.
Thank you.
Thank you, Bhavi. Amazing. We'll invite Rick up next. Rick's going to speak about choosing an optimal sub-exposure for astrophotography with recent examples from Bortle, Mississauga. All yours, Rick.
Okay. Share here. Okay. Just try to get this in full screen for you. Okay, you seeing that okay?
Yeah, it looks good.
Okay. Yeah, so honestly, I was really blown away when I actually learned that there's a way to calculate an optimal sub-exposure time for astrophotography. And I learned it was, really critical to know this. So I really want to share this with everyone. And I'll show you a few examples as well from my work. So, if we think about it, it would be really great if we use really short exposures. If you use a really short exposure, you may not need to do anything fancy like guiding, and your polar alignment is more forgiving. There's a lot less effect of things like wind and seeing and ground vibrations. The shorter your exposure, the less you're affected by these things. And also, if there's clouds, satellites, or airplanes that ruin a very short sub-exposure, say of a minute, you can delete it and you don't worry about it. But if you lose an hour exposure, especially here in the winter, it might be a whole night's work. So you'd really be upset about that. And so basically, the longer your sub-exposure, the more you're going to throw away, all else being equal, unless you keep the poor subs. So why don't we use the absolute shortest exposure? And so that's what I want to talk about. So let's think about a pixel on our camera. And a pixel captures photons, just like drops of rain in a bucket. And it converts them into electrons. And what I'm showing you here is two different methods of collecting those photons. In the first method on the top, we have one longer exposure. And say we were collecting one photon every second. So we collect 9, 18, 27, and 36. And we just let them continue to build up in that bucket or in our pixel. And then we basically weigh the whole thing. We dump it all out and we read it and we get 36 electrons. The second method is we take many sub-exposures, but now we read it at sub-intervals. So after 9, 18, 27, 36, we actually read the value in there. So we dump it out at each point and it then fills up again. We dump it, it fills up, we dump it, and so on. In the end, though, we get the same number of electrons. So the message here, and it's pretty simple, is that the signal is exactly the same with either method. The only thing we lose is every time you do a read, you do take a little bit of time, and that can be up to a couple of seconds. So it takes a little bit of extra time if you do a lot of reads, but only if your exposures are very short. So the amazing thing then is the fainter signals are detected just as well with short sub-exposures as longer ones. And that seems counterintuitive, but you don't miss anything by taking short exposures as long as you do it properly. And that's what this the rest of the talk is about, how to choose that exposure. Okay, so the reason you can't do a really, really short exposure or as short exposure as you want is because every time you do that read, you get some noise. And that's called read noise. And it's a property of the camera. My own camera has fairly low read noise. It's about 1.4 electrons every read you do. Apparently, there's some cameras coming along that won't have any read noise. And so that's going to be really exciting. But for the moment, it's fairly low. And this is quite typical. You can get down as low as maybe 1 electron right now for some cameras. So with the shorter sub-exposures, where we read 4 times instead of 1, we do get more noise. But the interesting thing is noise, like errors, adds in quadrature, which means we take this a square root of the sum of the squares. And so that means if we take n reads, we get the square root of n increase in noise. So 4 times the sub actually gives you 2 times the noise. So 2.8 versus 1.4. So in this case, where we just are looking at read noise, it's, in other words, read noise is larger than the other noises. Clearly, the longer subs are better. They're less noisy. But the fact of the matter is, other noises are often bigger. And the key one we have to worry about is the noise that comes from the sky background. So in my Bortle 8, I get about 6 photons every second with my setup coming into an individual pixel. And so if we have 3 second, 6 seconds, and 9-second exposures, then we get 18, 36, and 54 photons. Now, the interesting thing about counting photons, counting anything, is you end up getting what's called shot noise or Poisson noise, because it follows a Poisson distribution. It's a random noise, and it's just a physical fact, because you're counting something that's in discrete droplets. And so the actual noise, you actually generate a noise from the sky background that is proportional to the square root of the time, the total exposure time, and the sky brightness, basically how many photons are coming into that pixel. So in this case, I'm only doing 3-second subs, but in my Bortle 8, 95% of the noise in my image is coming from the sky. And the read noise is just 5% of the total noise. And again, this is because of the special way that noises add. So you can see one long exposure gives us 7.3 electrons of plus minus 7.3 electrons of noise at the end of the 9 seconds. Whereas, and once we read it, it only goes to 7.4. And with the shorter subs, you can see at the end, we end up with 7.7 versus 7.3. So there really is not much of a difference between anymore in terms of read noise. It doesn't really matter what your read noise is. And in fact, we consider this optimal because if you look at the shorter exposures of 3 seconds each, if we went to 9 seconds, we triple our exposure, we're only getting 4% less noise. So there's very little gain now from going any further in your exposure time, just from the 3 seconds. And again, this is because my sky is bright and there's so much noise coming from that sky, those sky photons. Okay, so let's, oops, sorry. So let's do one more example. And this is now an example where I'm using my L extreme filter. So it's a narrowband filter. It cuts out a lot of the light pollution. Now the sky brightness is much less. It's only 0.2 photons per second for each pixel. So now I'm going to choose for illustration a longer exposure time of 60 seconds for the subs. So the total here for the long exposure is 180 seconds. And the bottom, each exposure is 60 seconds. And again, the message is exactly the same. So on the top, the noise without reading is 6 at the end of 180 seconds. It's 6.2 with a read. With the 3 reads here at 60 seconds exposures, the noise is only 6.4 compared to the 6 or the 6.2. So again, you see that with 60-second subs now, with my L extreme filter, 93% is noise from the sky and only 7% is noise from the read. Now, so this is where it gets really important, because for me with my setup, 60-second exposures are very doable because my setup is portable, I don't do any guiding, and I get very few bad subs under those conditions. If I were to go 3 times longer with 180-second subs, I'd require a permanent mount and guiding, and it would only reduce my noise by a few percent anyway. So it really, in terms of noise, it's really not worth the effort. Now note, the darker your sky, the less photons coming from your sky background, the longer your subs need to be. So without a filter, I could run at 3 seconds to be optimal. With a filter, I have to go to 60 seconds. Okay, so that's the basic message. And so what I want to say, I think it's really important that anyone who wants to do astrophotography really understand what their optimal sub-exposure time is. That is, what exposure time should you use to get 5% contribution for read noise in that sub-exposure? And it's a very simple equation. The optimal sub in seconds is 10 times the square of the camera read noise divided by the sky signal in electrons per second. So you need to measure your camera read noise you can get from your camera specifications. Your sky signal has to be measured. And you want to take the most challenging case, so your darkest sky. And that way, if your sky isn't as dark, you know you're going to be in good shape. So what you want to do is look at the darkest sky at the zenith when it's fully dark at night, take an exposure of any length, then cap your objective and take a dark of equal time, and then just measure the background signal in any area of both the light and the dark. And what you'll get is a 16-bit ADU value. It's a digital unit from 0 to 65,535. And for example, Nebulosity is the free version of Nebulosity can do this for you. So once you've measured that, then you just subtract your dark ADU from your light, divide by the exposure time in seconds, and that now is your sky background, although it's in ADUs per second. And to get electrons per second, you just multiply by your camera gain in electrons per ADU. So I didn't want to go too much through all the math here. I know there's a lot to take in with this, but just want to give you the general perspective of how to do this, and hopefully there's enough information here that you can do this, or you can feel free to contact me if you need any help with it. Now, I didn't do any of the theory here. Two good pieces of work are Blair McDonald and RASC recently in February 2021. And the other one is Robin Glover. He has a lot of videos on YouTube, and he goes through all of this. And he also points out if you use his Sharp cap for acquisition, it will do all of this mostly automatically for you. So you don't really have to go through all this manual work to figure out yourself. Okay, so I just wanted to show you some of my more recent photos to show you some examples. So this is IC 1396A, the elephant trunk. It's part of a much bigger nebulosity. So this was optimal sub-exposures of 67 seconds each. And it was about 40.6 hours from September to November using the L-Extreme filter. It's nebulosity is about 2,400 light years away. And as you can see, there's a dark globule of cold, dense gas in the core. And this is a birthplace of new stars, by the way. And then it's surrounded by this hot hydrogen gas. And that's excited by the luminous blue star at the top. And that's giving off UV radiation, which is exciting the hydrogen, and that's giving off hydrogen alpha red light. So that's the predominant red in this image. The second image is probably familiar to everyone. This is M57, the Ring Nebula. It's about 2,000 light years away. This was taken with the L-Extreme filter. This is about 20.5 hours over 11 nights from August to November. Now, actually, these inner parts of the nebula are really bright, but I needed more than 1,600 sub-exposures of about 30, 45, or 60 seconds each to capture the very faint outer shells that you see here. The red and blue-green in the outer shells is very faint. I use shorter exposures on windier nights because my telescope is sitting out. So if it's a little bit windy or the wind is gusty, I tend to go to a little bit shorter exposure to maintain optimal quality. And so I don't need to delete many sub-exposures. Even at 30 seconds, I'm adding less than 5% more noise to my subs than the longer sub-exposures. So that's better for me than having to discard a lot of subs. but typically I do try to run at 1 minute if conditions are good. Now in this nebula, the green-blue color is due to oxygen, O3, doubly ionized oxygen. And the red color here is equally from hydrogen alpha, so from hydrogen, and also from ionized nitrogen, N2. And the structure actually is a result of a star that started blowing off gas about 1600 years ago, in its path as it's evolving toward a white dwarf. And NASA has a nice picture showing a 3D structure that's a donut. So that's the part here. You can imagine that's a donut, the hole in the middle. But the green part in my image is actually football shaped. So it's bipolar, sticking out and back through that hole in the donut. So it's quite a nice picture if you go to NASA's site. Okay, so those are two of my recent images, and again, you know, I really recommend everyone who's into astrophotography really look at their optimal exposure so you understand where you are. Any questions?
Thank you, Rick. Really great presentation. Any questions for Rick?
Hi, Rick. With regards to signal to noise ratio,
Yep.
How does that, so we're talking about optimal or managing read noise and managing noise from the sky.
Right.
In terms of if you're going for dimmer objects in a brighter sky, how does the signal to noise ratio factor into that?
Well, okay, so so the fact of the matter is your signal is the same however you do it. So the way to think about it is your sky background is the dimmest part of your image, right? You can't have anything less than your sky background. So any stars or nebulosity are sort of some small additional photons sitting on top of that sky background. So the signal to noise of your sky background is very close to the signal noise of the faintest thing in your image. So the thing is, by controlling my sub-exposure, then I can make sure I'm not contributing any extra noise or very little extra noise to the sky background. And that's the best I can do for my sky background. But if my sky background is lower, obviously I'll be in a better situation to see the fainter stuff that's sitting on top, right? Because you'll get a better contrast, if you will. Does that make sense?
Yeah, so
but the signal to noise of the faintest part of the image, it doesn't depend on the sub-exposure time if you've chosen it correctly.
right. So you made a comment earlier about filter and no filter.
Yep.
And in your particular sky conditions, mine might be a little bit different. The filter allows you to triple your integration time, or is it more than that? What did it end up being for you?
Oh no, for L extreme, it's like over 20 times.
20 times, yeah.
Yeah.
Okay.
Yeah. So it's a huge difference, and so the end result is obviously I get much better contrast with the filter, right? Because I don't have so much sky background, and I don't have so much noise from the sky background.
Yeah.
So you can never do, you never can do as well, say in Bortle 8 as you can do in Bortle 1, but you can optimize for your conditions. So you're doing as best you can in your conditions.
Yeah, perfect.
All right, thank you so much, Rick. Really appreciate you sharing your presentation with us. Randy, 50 years since Apollo 17, and welcome back. Thank you. Randy, are you still with us? Oh, there you are. Thanks.
I am. I'm working on it. Let's see. Oh, there we go. This thing is giving me a hard time. Does that look? Does it look okay?
Looks
Looks
great.
good.
Okay, thank you. Okay, yeah, let me give a little presentation here. Of course, anytime you start talking about something that happened 50 years ago, it kind of tells you how old you are. But if you've been watching Sky News over the past couple of years, Chris Gaynor and I have been writing articles on the 50th anniversary of the last 4 lunar missions. And this week, if you were a couple nights ago staying up late after midnight, you would have seen the launch of Apollo 17. And this weekend would have seen the landing, and early next week, the last 3 moonwalks of the Apollo mission. So I wanted to take the opportunity just to give an overview of the mission and some personal thoughts of it. So the launch was supposed to be December 6th at about 9:30 in the evening. Really was the second delay of the Saturn V launch. The first one was an Apollo 14 40-minute weather delay, but Apollo 17 had some ground support equipment problems that delayed it for 2.5 hours until after midnight on December 7th. The landing was December 11th, so that's Sunday. It's the 50th anniversary of that, and a splashdown on the 19th of December. There were 3 moonwalks, nearly 22 hours of length in total. The crew drove 35 kilometers in their car and brought back a lot of rocks and samples. The interesting thing about Apollo 17 was that there was some uncertainty as to who the 3 members of the crew would be, primarily because the Apollo missions were cut back. There was supposed to be missions all the way up to Apollo 20. After Apollo 11, there was a great drop in interest, not only from the public, but from Congress, as to how many more missions there would be. And after Apollo 13, there was even more interest in cutting back, with the idea that there might be a loss of crew. Plus, Richard Nixon didn't want to see any missions during 1972 during his re-election year, because he thought an Apollo disaster would not help his campaign. And there was a lot of concern about the cost of each mission, money that could go to the Vietnam War. So you could see that the interest in Apollo really fell off very quickly. So Apollo 17 was going to be the last mission. And the way things worked, there were backup crews for every mission. And so the backup crew for Apollo 14 would normally skip 2 missions and fly Apollo 17. So the 2 pictures at the top show the backup crew for Apollo 14. In the center, Gene Cernan, the commander. On the right, Ron Evans, the command module pilot. And on the left, Joe Engel.
Randy, we're not seeing your presentation. We're just seeing like the first, like your open screen. Maybe you're presenting it on a different window.
Oh, geez. Yeah. Okay. Stand by. Sorry about that.
Okay.
Okay.
That looks good. Yep.
Okay. Thanks, Rob. Okay. So the top, you see a crew of 3. Again, Gene Cernan in the center, Ron Evans on the right, and Joe Engel on the left. Joe Engel was to be the lunar module pilot. The Apollo 15 backup crew at the bottom, Dick Gordon on the left, Vance Brand in the middle, and Jack Schmitt on the right. They would have been the prime crew for Apollo 18. But Apollo 18 wasn't going to happen. But Jack Schmitt was a geologist, and he was scheduled to be the first real scientist, geologist to be on the moon. And there was a real concern about this. So in fact, what ultimately happened, which was took months to decide, but Joe Engle lost his seat to the moon, and Jack Schmitt was moved into his position. So that was kind of an unheard of thing, but again, it was the last flight to the moon. So fortunately, the science community won, and the scientist flew to the moon. And now I can't, oh, there we go. I like this slide just because it shows you how big the first stage of the Saturn V is compared to the little people there. This was the last crewed flight of a Saturn V. The astronauts at this point were dedicated to a true science mission, the last flight of Apollo to the moon. This is Cernan practicing drilling into the lunar soil to take out a very long core tube, but also to insert a heat probe into that hole to measure the heat coming out from the moon. At Kennedy Space Center, the lunar module is flown down from where it's built in Long Island to the this building, this very clean building, where they process the lunar module and all of the equipment. This fellow here, Fritz Weideck, he'd been with NASA since the Gemini days, since the mid-60s. And I noticed this picture. I thought it very interesting. So actually, when I was down in Florida during one of the shuttle missions, I looked him up and called him up and actually went and visited him. And a very interesting guy. He was a real sailor, and he had like a sailboat in his backyard, because in Cocoa Beach, you've got all these waterways and everything. But right in the middle of his living room, he had this big piece of furniture that was all painted white, and it had been autographed by every astronaut who had flown in space. So he was really, a long-term space employee. But I was interested in his wrists in this photo, and I talked to him, and he said, well, we were playing a softball game with the crew of Apollo 17 and a whole bunch of support people, and I slid into second base and broke both my wrists. So you get an idea of how close-knit these people are to each other as they get ready for such an interesting mission. But he was involved in supporting all this, where they get the astronauts in their suits, in their flight suits, in the flight lunar rover, test everything out before they folded up the lunar rover and put it in the lunar module. And you see that they still have to add the legs and everything, but then the process would be to get move it all out to the launch pad, and that they did in August of '72. So it sat on the pad for several months before the launch. Kind of wish I'd taken this photograph, because it was early in the afternoon of December 6th. But unfortunately, I did not go down for that launch. But not many people there compared to a lot of shuttle missions I was down for. But the neat thing about Apollo 17 was, because of the date and the time of the landing 3.5 days later, and the position of the Earth, Moon, and on the ecliptic and everything, it meant it would require a night launch, very similar to the SLS launch that took place a few weeks ago that had to take place in the middle of the night. But it was the first and only launch of the Saturn V. And I was at the first launch of the shuttle 11 years later. And there were a lot of people there who had seen this launch, and they compared this to the shuttle launch. And they thought the shuttle launch was a bit brighter. But the Saturn V takes a long time to get off the pad and make its way up. And so they thought that this was a little bit more impressive, and certainly a lot louder with the large engines on the Saturn V. About 12 hours after launch, the crew was on their way to the moon, and they looked back and saw this amazing full Earth picture. And so this is an amazing, well, very famous picture now. And it's interesting how it shows several things. It shows Africa. It shows the fact that it was taken in December with the southern hemisphere pointed toward the sun. Great view of Antarctica there, which is going to come up a little bit later in my presentation. But also when Betty and I were in Idaho for the lunar solar eclipse in 2017. We visited a museum which had an Apollo exhibit, and there was the Hasselblad camera from the command module. It didn't explicitly say that it took this picture, but I'm pretty sure that it did. So that was kind of neat to see that. So a few days after launch, the crew were in lunar orbit, and Cernan and Schmidt separated from the command service module with Ron Evans in it. You can see just down below there, the command service module in a lower orbit. And they landed on I just looked it up. It was a Monday afternoon around 2 o'clock or whatever. I don't know why I wasn't in school, but anyway, I remember watching the landing, and it was one of the most nominal, no problem landings of the entire Apollo program. And that just seemed to be the case with Apollo 17, which was interesting because, of course, a lot of the people working on this hardware were out of a job after the last Apollo mission, but all of the systems and the hardware and software, everything just seemed to work really well for the last Apollo mission. So here you can see the Challenger lunar module on the moon. On the left-hand side, left of the ladder, you see this big white structure there. That it was actually, it unfolded as Cernan came down the ladder. They call that the MESA, the mobile equipment's, I don't know, structure assembly or something. I don't remember. But that's where all their equipment was. And they're on the right-hand side in that bay, that's where the lunar rover was. So as the crew came down, they just set up the rover and got ready for flight. I show this because just to show it being on the moon. A few hours after the landing, I took out my telescope and actually took this picture. And so I remember quite vividly looking at it and knowing that there were 2 people on the lunar surface and 1 person in orbit when I took the picture. So there's Cernan testing out the lunar rover for the first of 3 missions. Setting up the flag, of course, was standard. This is a great view of why the flag appears to be waving, because there's this rigid rod along the top of the flag, just to make sure that it doesn't fold down. So of course, people who saw the flag waving said, well, there was no wind on the moon, so all of this was faked. And of course, they don't understand what a plastic rod can do, I guess. TV from the moon really improved over the missions. Top left-hand corner was Apollo 11. Top right-hand corner, Apollo 14. That's Al Shepard shooting a golf ball with a 6-iron there. Improved vastly with the first lunar rover, Apollo 15 on the bottom left, and Apollo 16 on the right, John Young saluting the flag and jumping up. But Apollo 17 was amazing. The clarity of the video was great. Here's Jack Schmidt actually telling Cernan giving him instructions on what to do, and he lifted his gold visor, and you could actually see his lips moving as he talked to the other astronaut. So this is some examples of some of the clarity of the video. Setting up an experiment on the moon, walking near the lunar rover, taking some samples. I had a camera set up with black and white Tri-X film. I took a whole bunch of photos, but I really like the bottom photo because it's kind of unique. Here's a live from the moon shot. The thing that bothered me was I was all set, I was in high school at the time, all set to watch the mission, and the media had just lost interest. And so instead of showing all this stuff live, they put together a little half-hour summary just before the Johnny Carson show at 11:30. And it was, I guess it was very disappointing. But that was also some indication of where we had come. This is the 6th landing of people on the moon, and people weren't interested anymore. So here are some pictures from the Apollo 17 mission. Very, very productive. Certainly with Jack Schmidt on the mission, he was able to identify a lot of the samples. Although the Cernan had had reached a point where he had taken some geology classes, and certainly Schmidt had helped him along. So it sounded like they were both similarly educated in geology. And what's interesting is, if you read Cernun's book, is that Schmidt, who didn't know how to fly before he became an astronaut, became quite a competent jet airplane pilot as well. So very, very capable people who learned a lot about their craft before they flew to the moon. This is a picture from the second mission, second moonwalk, Shorty Crater. It's a great, Cernun walked up this rise to take these series of photos, which are merged together into a pan. And you see Schmidt at the rover. Just to the right of the rover, you might see a hint of orange on the ground. That was orange soil that they discovered. And there was great interest from the geologists on the Earth, because they thought they had possibly discovered a volcanic vent, which was something that they thought they might discover at this landing site. It ended up being just some glass as a result of a meteor impact billions of years ago, but it was quite an interesting thing. That little device on the ground there is what they call a gnomon. It's spelled G-N-O-M-O-N, a gnomon. It's a geologist's tool to show colors for your camera registry, but also that top little pole actually shows it wiggles around and will identify local vertical. So it's something that they always placed in front of an area where they were taking photographs of something on the surface. So the rover was quite an amazing vehicle. And they had a little bit of a problem with the one on Apollo 17. Cernun had a geologist hammer in a pocket on his leg, and it caught one of the fenders on the rover and ripped it off. And as they were driving, the lunar dust would spray up and fall on top of the astronauts, making it a real mess for them to clean up after their moonwalk. So they, during the first overnight, they fashioned a new rover fender out of lunar maps and duct tape. Of course, you always take duct tape to the moon, and some clamps from an optical sensor that they had in the lunar rover. And one of the astronauts on the moon, who had been on the moon on the previous mission, fashioned all this, John Young, and they put it on. It did a great job. It kept the lunar dust down, and they were able to proceed with the mission. And if you go to the Air and Space Museum, they brought it back, and so the makeshift lunar fender is on display. This is Gene Cernan after, I think, the third moonwalk, and you see why the astronauts talked about walking on the moon was like working in a coal bin, because the lunar soil was just very dirty and grimy, and all that stuff came into the lunar module, and they didn't have much room in the lunar module to do anything. And the two astronauts had to take off their suits, and it was quite an ordeal to clean up after a moonwalk. His suit was on display when I was there a while ago. I know the Air and Space Museum has gone through some renovations, and they have a new Apollo display, but I'm sure they still have his moon suit, and they could never get it clean. So there's still a lot of lunar dust in his suit. So after the three moonwalks, the lunar rover was parked east of the LEM, and the video from it could show the takeoff of the Challenger ascent stage. And a little while later, the ascent stage met up with Ron Evans in the command module. You can see Cernun's face there through the commander's window. And so there are 6 of these descent stages sitting on the moon, waiting for someone to come back and visit them. And a few days later, the crew landed in the Pacific, and the lunar surface exploration program of Apollo was over. And of course, we're all looking forward to the next time that people walk on the moon, which is supposed to be within the next few years. The crew after the mission, Cernan was at all of the early shuttle missions, was a correspondent or commentator for ABC. This was the second shuttle mission. I caught him talking to Walter Cronkite. Jack Schmitt actually went into politics and became a senator in New Mexico, and he was at the landing of the third shuttle mission in New Mexico, and so had a chance to meet with him there as we waited for Columbia to return. Years later, these Apollo astronauts, they tended to be involved with these various fundraising events. This was one in 2012 in Kennedy Space Center. There are a lot of Apollo astronauts there: Dave Scott, Jim McDivitt, who just passed away recently, Tom Stafford, Buzz Aldrin, Gene Cernan, who passed away a few years ago, Charlie Duke, Apollo 16 moonwalker, Dick Gordon, Fred Hayes, Alan Bean. Here's a unique shot that I took at one of those fundraisers, the first and last man to walk on the moon, Armstrong and Cernan. And recently, just a few years ago, Jack Schmitt was at a seminar at Western University in London, and the fellow, the second from the right, is Dr. Stuck, Phil Stuck, who gave a talk to our center several years ago about Mars. And the fellow on the right is actually Bjarne Tryggvason, Canadian astronaut who unfortunately passed away a few years ago. So yeah, this was just a few years ago in London. Gene Cernan wrote a book about his experience, Last Man on the Moon, and it was turned into a movie. And it's possible that many people on the session tonight were at the TIFF, Toronto, or a docu, Toronto Docs or something like that. Anyway, Cernan was there for that when they premiered his movie. Ron Evans, unfortunately, passed away rather early in the early 90s from a heart attack. But a book just came out recently that I read. It was very good, very interesting guy. Wish I had a chance to meet him. And Jack Schmitt wrote a book about returning to the moon as a lunar geologist, what it would be like, what we should be doing as we head back. There's been a mission to send an unmanned spacecraft with a rather long lens to in lunar orbit, the Lunar Reconnaissance Observer, and it imaged all of the landing sites. And this is the Apollo 17 landing site as it looks right now, showing a descent stage and the rover final spot. And you can see the albedo of the lunar surface change based on the astronauts walking and working. So pretty good evidence that they were there, but you never know. If you're interested in Apollo 17 and interested in more information, even though a lot of the video was not available real time, it has come out on DVDs since, but a lot of it is online now. All the transcripts are available, photos are available, audio, YouTube, mission reports. As I mentioned, Chris Gaynor and I have written articles about the last 4 Apollo missions on their 50th anniversary. So this is in the current issue, November-December issue of Sky News. It is kind of, I talk a little bit more about just how interest had waned in Apollo, and how, I guess how it affected me a certain amount, but also the fact that Nixon was looking to, and some of the people at NASA were looking at stopping after Apollo 15. So kind of an interesting history. There is an online site called Apollo 17 in Real Time by Ben Feist. Ben has actually given 2 talks to our center. When he created this one, this was the first one he created. Then he created an Apollo 11 in real time, along with the movie that he was involved with. This is an amazing site that you can essentially go on after this meeting and essentially follow along Apollo 17 during its mission. I looked at it for right about now. This afternoon, I set it to about 9:30. The crew's about halfway on the way to the moon right now. they were donning some blinders on their eyes to perform cosmic ray experiments. A lot of the astronauts saw flashes due to cosmic rays actually passing through their heads and hitting their retinas. And so you've got any photographs that were taken at the time appear there. You have the transcript and the audio. And during the lunar walks, any of the video that was taken appears real time. But also at the top here, you can adjust the time so you can watch any part of the video you want to. It's an incredible resource, and Ben has just done an amazing job with this. So that's my talk. I'll take any questions. I wanted to just show a few other things as a few people have been suggesting. Betty and I just got back from a 2-week trip to Antarctica, and it was an amazing trip. And I just wanted to show just a few pictures, not many, because we're probably going to put together a more extensive presentation for a future meeting. But this video coming up gives you a real idea of our experience on Antarctica. And I think this video is from about a week ago, like last Saturday. So that's the two of us there. So we're just walking along this path, and the rule was you had to give the penguins the right of way. So if they stopped in front of you, you just had to wait until they got out of the way. But when the video replays, look at the top, and you'll see a whole bunch of black areas. Those are all penguins. So I don't know how many penguins we saw, but we saw a lot, many rookeries. But the geology there was unworldly. We saw stuff that we had no idea we would ever see. Things like this, icebergs, penguins. It was an amazing trip, and we're looking forward to sharing it with you. And if you have any questions about my talk, I'd be glad to answer them. Thank you.
Amazing photos across the board. Great story. Check out Randy's article in the November-December Sky News magazine. I posted the link. Any questions for Randy? I have one. How did they get the lunar rover parts into a small capsule and ship it over to the moon?
Good question. All the legs folded in on top of that rectangular body of the rover, and then it just folded up. So if you actually saw a picture of the lunar module with the rover installed, it stuck out. The base, the bottom of the rover, the big flat thing, would be sticking out from the LEM. And then they actually had lanyards where they could release the top and then fold it down, and the wheels opened up. And it was very ingenious. And, it was electric. The wheels were made of piano wire, believe it or not. And it was amazing vehicle.
Oh, for sure. No, that's great. Any questions for Randy?
Yeah, Randy, Ron McNaughton here. Did they have some system for dust removal in the LEM? Because there would be air there. Do they have vacuum, like tiny vacuums to clean it up? Because you wouldn't let to leave dust in the seals of the spacesuits, because then they would leak. And if not, are they doing something like that for Artemis?
They had brushes that they would brush each other down before they climbed up the ladder. I believe they had a vacuum inside the LEM. Cernan commented that after 3 moonwalks, things began to not work anymore because of the dust. And they realized that the lunar dust long-term was going to be a big problem. The other problem they ran into was once they got back into lunar orbit, of course, it was free fall and all the dust was flying around. And in fact, the great story from Apollo 12, was that Richard Gordon, wouldn't let Charlie Conrad and Al Bean back into his clean command module. They had air going from the command module into the lunar module, but he made the crew take off their spacesuits and all of their clothes and put them in bags. And Conrad and Bean actually floated back into the command module in their birthday suits, which, I mean, one of the weird stories from Apollo. But it was such a concern that you didn't want all this fine dust to contaminate. So one of the major challenges for long-term exploration on the moon is dust. I'm sure people have been working on it ever since Apollo.
Paul has a question.
And Randy, I was watching the documentary on NASA channel the other day about the landing of Apollo 17. And I've always wondered what the contingency plan was if the rover broke down at its farthest point from the lander. Did they simply walk back? Or?
Yeah, they always had they always planned for it to break down. And in fact, where we saw the orange soil was the farthest point that they got from the LEM. And if you go to the website and watch that part, they see the orange soil, and Schmidt goes, well, very excited, I've got to dig a trench, I've got to do this, I've got to do that. And they were running out of time. And they talk about the walk back contingency. And, the mission control is saying, okay, you guys have 10 minutes before you have to leave here. And they were just hustling to try to do all of the work that they wanted to do on those samples. But they always had in mind the walk back contingency point, given, I don't know how they calculated how fast astronauts could walk back, especially if it was, a far distance. But not only did they have that kind of thinking, they had a buddy system where one astronaut could actually plug hoses into another astronaut in case his backpack broke. So they're always working on the what ifs, and they definitely had a walk back contingency.
Well, thank you, Randy. We
Hey.
look forward to your Antarctica presentation. Just a reminder, Orion is returning to Earth on Sunday. I did post a link. Coverage on NASA TV starts at 11 a.m. Eastern. It's probably supposed to go till about 2:30, so I'll be glued to the TV. I hope you are too. 13th January is our next Potpourri. Wishing everybody a very happy holiday season and a safe holidays. Please keep yourself safe. Thank you to Rob, my co-host, who helped us with today's meeting, and thank you to the great presenters. We'll look forward to seeing you all in the new year. Bye, everybody.
Hey, thanks, Rob. Thanks, Swatman.
Oh, no worries.
Thank
Take care,
you.
everybody.
Bye.
Everybody,
Happy holidays.
Happy holidays.
happy holidays.
Happy holidays, everyone.
Yeah, happy holidays.